Hey guys, this is Coder Jeet, your best friend in programming, and today I'm going to talk about state management in Blazor WebAssembly. Now the web is stateless, which means that a server fulfills a request and promptly forgets about it. It does not maintain all that user information in memory, and that's the only way it can serve thousands of users at the same time. And yet we do need to keep the user's information or state somewhere and make sure that the web application that you have created works hassle-free. That is possible through the various state management techniques available to you, and in this video we are going to see some of them that you can use in Blazor WebAssembly. So let's get started. There are 5 major ways you can store this state. The first is in-memory storage right on the browser, and the second is to store in URLs. You can use query string parameters. Then you've got a state container that's also on the browser, and you also have client-side storage techniques using the local storage and the session storage that's a part of the browser API too. And finally, you can connect your client-side identity to a server-side database and store a lot of information on a server-side database too. We're going to explore all of these methods. Let's see how this works on the standard Blazor WebAssembly app. This is it. And it's got 3 pages. There is a home page, there is a counter page where you can click a button to increment a counter, and then there is a fetch data page which gives you some temperature forecasts for some cities, and this is all random generated data. It's not being pulled from an API, so this is not authentic. Let's store some value in application state and show it across all these 3 pages. Here we are in the code. And to maintain the state, we need to add a class where we'll actually store all the information. So let's create a new class and let's call it app state and add it. This has to be a public class, of course, and this is where we will declare all the properties that will hold our state. So let's create a property called counter. If you remember, in the project there was a counter. You can click a button and increment a counter. Let's just make a system to show the counter value across all the pages. So we will create an integer variable called counter. Let's just use the short form declaration get set, and that's it. We have declared our variable, and if you create an instance of the app state class, you will be able to refer to the counter variable. The next thing to do is go to the shared folder and find the main layout. If you've seen other Blazor tutorials from me, you already know about the layout pages. You use layout pages to declare code and markup that is common to the entire app. Here you can see some HTML markup, and you will also see the body declaration, add body. This is where the code for all the child component goes. So when you have a component which is based on this layout page, it will first have the markup for this layout page, and right where you put the body declaration, that's where the child component will put all its code. So what we got to do now is first create a code segment. This is where we can put in any C# code, and we will declare a variable of the type app state. So let's call it app state, and let's call the variable name application state, and it's a public variable, of course, and we will create a new instance of it. All right, let's not forget the semicolon. And that's it. Now this variable is a public variable in the main layout, and the next thing you want to do is create a cascading value element and set the value to your application state variable, and then put your body attribute inside the cascading value. All right, that's done. Now what's going to happen is all the components that derive or that are based on this layout will have the cascading value application state passed to them, and they will be able to access the application state and see what's set in there across all the different components. And now your application state is available to all the 3 pages. Let's see that in action. So we've got 3 pages here, and we want to access the application state in all 3 of them. Let's start by going to counter. And what we need to do is declare a variable of the same name and the same type, of course, and then decorate it with the attribute cascading parameter. What cascading parameter does is it tells this component that the value for the application state or whatever variable you have here will be set by the parent component. Now let's do the same in the other two pages that we have. Fetch data and index. Alright, and now we have to show the value in all three pages. The first thing we want to do is update the value of the actual counter in the application state, and for that we're going to go to the counter page and you will see this function called increment counter. This is incrementing a current count which is a local variable, and that's being displayed on the page. What we're going to do is inside this, let's also increment the counter in the application state. So application state dot counter plus plus, we're going to do that, and now the application state counter will also be updated. And let's add another paragraph over here and let's show the application state current count. So application state counter value, and instead of showing the current count, we're going to show application state dot counter. Alright, let's see this in action. Here we are, we've got two counters now, and when we increment it, both the counters are getting incremented. One of them is from the local variable and the second one is from the application state. Now let's display the same state in the other two pages. Here we go. Let's just put it here right near the top, and we'll also put it in the index page right over here. Now let's run it and see what happens. So here we are, the application counter value is 0 in the home page. Let's increment it, and then when we go to the home page it's 5, and when we get to the fetch data page it's 5 again, and we can increment it here. It will be reflected in the other two pages. You can see the URL is changing too, the main component is changing, and the state is conserved across all the three pages. One more thing you want to note, the local variable that we have there, that is not the same value as the application state, because that is initialized every time when this component is loaded, but the application state is conserved. So this is how we keep the application state using a cascading parameter value in memory. The next method is keeping the state in a query string in the URL. Well, this method is actually good only if you have very little information or data to transfer, and we use query string as a state when you want to transfer some information from one page to another. So let's say you want to transfer some data from counter to fetch data, you can use a query string parameter, but you cannot just use it like the way we're using an independent application state class and just click a button and update a variable and see it reflected across the entire application. That is not going to work. To make it easy to work with query strings, we need to install a library called Web Utilities. This is made by Microsoft, and we can install it using the package manager. I like the package manager console. Just fire it up and you can use the command install package microsoft.asp.NET Core.WebUtilities. And these utilities can be used not just in Blazor projects but also in non-Blazor ASP.NET Core applications. Just press enter and the latest version will be installed. Now you want to make sure that you install it both on the server and the client app. There are multiple projects in this particular solution, and we're going to be using Web Utilities in the client side, so just make sure that you install it on the client side too. Once it is installed, we can start using the Web Utilities. To do that, first we need to declare a using statement using Microsoft.asp.NET Core.WebUtilities, and you need to do that in every component where you're going to use these Web Utility classes. And the second thing you need to make the query string handling easier is the navigation manager class, which is a part of Web Utilities, and we're going to declare an instance of it using injection, using dependency injection. Let's call it nav manager. Next, what we're going to do is let's make a new button to handle the navigation, right? Because clicking on the sidebar is not going to work, because that's not going to take your query string variable to the next page. Let's create a new event handler called transport state, and this will be the event handler function responsible to navigate to the new page and transfer your query string to. So let's declare that. It's a private function. And in that function, we're going to use the nav manager. Nav manager dot navigate to. This is the command to navigate to a different URL. And we're going to use the query helpers class, which is also a part of the web utilities. There is a function called add query string, which will create a URL and append the query string variables that you specify. And it expects a dictionary of string. So let's declare that over here. Dictionary string comma string vars is equal to new dictionary string comma string, and let's specify the values. Let's call the variable, the query string variable, counter, and let's put in the current count over here, current count, and we need to convert it to a string because it doesn't expect an integer. Alright, so this is it. Let's pass this over here. This should be it. Let's compile, run it. Okay, so now on the counter page there is a button called navigate, and when you click it, you get a counter query string variable with a value 0 right now because the counter is 0, and when you increment it, navigate it, this time the value is set. Next we need to retrieve the value and show it on this page. Let's go to the fetch data component and let's create a new paragraph to show the counter value coming from the query string. And this time we don't have the application counter. Let's create a new local variable over here, public. We have created that one, and here we go. And now we got to put in some value inside of counter query, pulling it from the query string. To do that, we can use the on initialized async event. That's just going to work fine for us. To do that, again, let's use the web utilities classes. Let's just copy this code over from the counter. Here we go. All right. And because we are an organized coder, we're gonna group these statements properly. Coming back, we will create a new variable called query string, and let's use the query helper again. We need to parse the query, and we actually need to get the query string from the URL, so we're going to use the nav manager URI property. But the URI property is actually a string, it's the entire URL, and we need to extract only the query string. So let's first convert it to an URI object instead of a string object, to absolute URI. That's the function. We're going to pass a string to it and then dot query. So this should work. Right, it is working. So it's going to parse the query and assign it to the variable query string. Next, let's just extract the proper counter variable from the query string. So query string, our variable is called counter, and we're going to assign it to an out variable. Again, let's call it counter, and we will need to convert it to integer because our counter query variable, the public property that we're using, is an integer, so we can parse it in 64.parse, and that should be okay. That should be working. All right, so it's called counter query, not country query. That worked. Okay, that it's an int 32, not int 64. So this should be working now, and if we run it, we should see some results. Let's do that. Here we are. Increment the counter, go to navigate. The counter value is set to 5, and you can see the query string counter value is also set to 5. Let's go to the counter again, increment it some more. Now the application state counter is at 11. The current counter for this page, initialized counter, is at 6. When you navigate, the value is set to 6 in the query string. The application counter is still retaining the correct value in the application state, and you get the query string counter at 6. So this concludes how to do it with the query string. Let's move on to the next one. The next tactic that we're going to look at is using the state container again, But this time, instead of using it in components that are a part of main layout, children of main layout, we're going to use this using dependency injection. And this is actually the standard way of using a state container, and I recommend it that if you're going to implement a state container, use dependency injection to implement it. Let's get started and see how that works. We've got the app state class already. Let's just make another copy of it and let's call it d app state. Gotta rename it inside to d app state. And now let's inject this as a dependency class in programs.cs. So we're gonna just use builder.services.add_scoped. Actually, when it comes to Blazor, add scoped, add singleton, add transient, they're gonna be all the same because this is a front-end technology. There is no call to the server at all when it comes to putting a dependency in the front end. So you can use add scoped, or you can also use add singleton, which I think is more appropriate when it comes to accuracy, but both actually are functionally the same. And then we just need to declare the type of the dependency, dapp state, and let's make sure we include it. What's going wrong? Dapp state. Oh yeah, the T is capital, and since C# is a case sensitive language, the T was not capital here. That caused the difference. So anyway, that's done. And now the app state is available to our views. Let's take a look and see how that works. We need to inject because it's a dependency that needs to be injected. The app state, d state. Let's call it d state. And now this is available. So we're gonna store the value in d state to d state dot counter plus plus. Same as before, and everything else is the same. We're just gonna show this. So let's create another little paragraph. Dependency state counter value and d state. Alright, this should be it. That's all the code I think we need to make this work. Let's run it and take a look. So when I click, you can see all three of them are increasing. Dependency state counter value is also changing. And let's put it in all the other pages and see. We haven't done it yet. So copy it over to the index page and the fetch data page. Let's see. We need to inject the dependency in all the places where we're gonna use this. Alright, that's done. Let's run it again. Here we go. Back to the counter, the value is increasing. When you go to the home page, you can see the application state counter is 6, dependency state counter is 62. Come back to the counter, the value of the current count is 0 because the page reinitialized. You increase the counter again, you go to home, and you can see the dependency state counter is changing too, and application state counter is changing too. Well, that was it for dependency state. All the state management techniques that we saw so far will keep your state in memory only till the application is running, and as soon as somebody closes the browser window, that data is gonna go away when the session ends. Well, what if you want to store your information just a little bit longer, to have your user come to your website maybe a day or 2 days later, or maybe even more, to have your user come back to your website a day or 2 later and find that they can resume where they stopped? Well, it's possible if you use the browser storage in Blazor. The browser storage system or the browser storage method of state management will store your information using the local storage facility of the browser itself, which will conserve the information as long as the browser cache is not wiped out. So your customer, your user can come back a week or 10 days later and still find that their session is still existing, the information is still there. Let's see how this works. Even though Blazor is a front-end technology, it cannot interface with the local storage directly. To connect to the local storage and to store items and get items from local storage, it needs to go through JavaScript. Luckily, Blazor has JavaScript interop, and you can call JavaScript functions and JavaScript objects through Blazor using that interop system. To work with browser storage, we need to use interop, and I have written a little class that makes this easier. I call it the JS storage class. And this class is included in the GitHub repo that I have in the description of this video, so you can find it easily. But what this class does is just call the JS runtime and invoke the local storage set item and local storage get item functions to store or read the information that you want to store in the browser storage. We can use the JS storage class as a dependency using the dependency injection technique that we learned earlier. Let's do that. So all we need to do is go to the program section, and let's just make another copy of it and copy JS storage from here, paste it, and now we have JS storage as a dependency which will be available to all the views that you have. Let's now put it in the counter. We'll use JS storage and let's call it JS storage. All right, and JS storage dot save. Give it a name, counter, and you can probably use the current count as a value. And now, since this is an asynchronous method, because local storage has to be read and written in an asynchronous fashion, we have to make this asynchronous too. So we're gonna make this an asynchronous function, async task, so that it can be awaited. Okay, we gotta just convert it to a string. Alright, that should do it. We have saved the value to the browser local storage using a function, and we gotta retrieve the value from the local storage using a function too. That means handling the storage is not going to be as simple or intuitive as assigning it to a variable. We have to do some extra work for this. First, let's create a public property over here called counter browser. Let's call it counter browser. And in increment count, we are also going to set the counter browser. We are going to make the counter browser value equal to current count. And that will update the counter browser on the page over here where we have this line, the paragraph browser storage state counter value counter browser, that will update it. But to retrieve the initial state of this variable when the component loads, we need to override the onInitialized async function, and let's do that now. Protected. And here we can retrieve the initial value of the counter browser and assign it. We have to cast it to an integer. And that's it. It should load up the initial value of the counter when we start the program. Let's run it and check it out. Alright, so as you can see, the browser counter storage is starting at 4, and when we click it, it changes all over again because we are setting the value to the current counter and not incrementing it. Let's modify this code a little bit. Instead of saving current count directly, we will increment the counter browser and we will save the counter browser to the storage. So now this will be maintained even if the current count is initialized on every component load. Let's run that. Here we go. We are incrementing the counter browser this time and the values are all different. The current browser is 2 numbers ahead. Let's close this and it should start back at 17. As you can see, all the other values are 0 because they were session based. The browser storage counter is at 17 and was not initialized. So if I increase this further, I'll close it and I'll start again. The state is conserved longer across browser reloads. You can switch off your computer and when you come back, you'll still find the value at 22. To implement it on the other functions, we gotta implement the onInitialized async pattern too. So we'll do that. Come back here. There is already an onInitialized function over here. So we'll just add the extra line that we have. There we go. We'll also declare the variable. Yep, the property is there too now. And let's retrieve it. Let's see how that works. So now we have the browser storage counter on the fetch data page too. So finally we are in the last phase. We need to store the data server side in a database. Now the difference between all of this is that so far we stored all our state on the client side, whether it was using the Blazor classes or it was using the local storage. It was all on the client side. Nothing was stored on the server side yet. But we can store information from the customer on the server side too, and that's what you've been doing all this time when you used ASP.NET Core or ASP.NET MVC. All the data you stored was on the server side, and the pattern is pretty much similar to that. What you need to do is you need to go to your Blazor project and you will find a project called Blazor State Server. This is the server side of the app that you're creating, and this is the client side. So far we worked on the client side, but on the server side you can actually connect to databases, and this is very important. If you're creating a Blazor WebAssembly project, you cannot connect to the database directly from the client side. You will need to do that on the server side. You will need to write all your entity framework or your database access classes on the server side and expose the functionality using APIs. That's what this particular project does. There is a pretty good demonstration of how to use APIs to consume the data. So I'm not going to write it there because the server side storage is already demoed in the code sample that is provided. This concludes this Blazor WebAssembly state management tutorial. If you like this tutorial, if you found it useful, don't forget to hit that subscribe button, like this video, and make sure you come back to me and watch this channel again, because we are going to see a lot of content on Blazor programming and on other programming topics. This is Coder Jeet, your best friend in programming, signing off.